So this is the second part of 11.4 part 2, more review on doing these 5 steps, and I'm going to do all 5 things to this one example, and then there's a whole bunch of practice problems for you to do with full solutions at the end. So this video shouldn't take too long because I'm just doing this page right here. All right, find the slope of this cardioid at theta equals pi. So step 1, before we can do anything, we need to write the curve parametrically. X is r cos theta. R is 1 minus sine theta. So x is 1 minus sine theta times cosine theta. And I'm going to distribute, that's cos theta minus sine theta cos theta. Y is r sine theta. So that's 1 minus sine theta, which is sine theta minus sine squared theta. Okay, step 2. Use the parametric slope formula. dy dx is dy d theta over dx d theta. It's really common to switch them by mistake and end up putting dx d theta on top. I do it too. I think it's just because x comes before y, but if you're getting your slopes wrong, maybe you have them upside down. So dy d theta, these will always require the product rule, by the way, because of the nature of x and y. So dy d theta is, I don't want to make the mistake I was just talking about. So I'm looking here at y, cos theta minus, use the chain rule, 2 sine theta cos theta. And in the denominator, we're going to have the derivative of cosine, which is negative sine. And then I've got a product rule, so I don't want to make mistakes. I'm going to factor out that minus and then use the product rule. The derivative of sine is cosine, so that gives me cosine squared theta plus the derivative of cosine is negative sine, so actually I have a minus here, minus sine squared theta. All right, and the only cleanup I'm going to do is distribute that minus downstairs. So I'm going to leave the top alone, cos theta minus 2 sine theta cos theta, and then downstairs negative sine theta minus cosine squared plus sine squared. Okay, that's step 2. That gives me the slope at any value of theta. I want the slope at theta equals pi. So now I'm down to step 3, find m. So 3, m is dy dx at theta equals pi. So I have cos pi minus 2 sine pi cos pi over negative sine pi minus cosine squared pi. And just so I don't make a mistake, I'm going to think of that as cosine pi all squared plus sine pi all squared. Now, of course, sine pi is 0 and cosine pi is negative 1. So on top, I get negative 1. And on the bottom, I get negative 1 squared, which is negative 1. So I've got negative 1 over negative 1, which is 1. So that's my slope m. Okay. Find an equation of the tangent line at theta equals pi. So I've already found the slope. I'm up to step 3. For the tangent line, I have to do steps 4 and 5. I need the point, x naught, y naught, and then I just plug it into point slope. So step 4, there's my bird, is x naught, y naught is x at pi y at pi. Now, x and y are up here on step 1. So x of pi, let's just do this in our heads rather than write it all out. Cosine pi is -1, sine pi is 0. So x of pi is -1. And then y of pi is 0. Finally, step 5. Y minus y naught, which is 0, is the slope, which is 1, times x minus x naught, but x naught's negative, so x plus 1. So y equals x plus 1. All right, and I can graph that on my curve. Find the equation of the tangent line at theta equals pi. That's right, x is -1, y is 0. So that's right here. And this is my tangent line. It's got slope 1, and it goes through 1 on the y-axis, and that seems reasonable. Okay, so do those practice problems, and then we're done with this section.